Why do some clouds not know how to rain? Think about it. A cloud can be packed with water, millions of tiny droplets floating right above your head. And yet, nothing falls. No rain. No snow. Just a sky, full of wasted water. So, here's the real question. If the water is already there, why doesn't it fall? And more importantly, can we actually force it to rain? Stay with me till the end. Because today on Earth Diary, we uncover how cloud seeding is far more powerful and controversial than you think. To understand cloud seeding, we first need to understand something surprising. Not all clouds are ready to rain. Inside many clouds, especially cold clouds, where temperatures drop below 0 degrees Celsius, there exists something unusual. Supercooled droplets. These are tiny drops of water that remain liquid, even below freezing. But here's the problem. They're too small. Gravity simply isn't strong enough to pull them down. So instead of falling as rain, they just float, suspended in the air. For rain to happen, these droplets need to grow bigger. And for that, something crucial is missing. Ice crystals. In cold clouds, precipitation usually forms through something called the ice crystal process, also known as Bergeron process. Here, ice crystals grow by stealing water vapor from nearby droplets, getting bigger and heavier, until they finally fall, as rain or snow. But in many clouds, there simply aren't enough ice crystals. So, the cloud is stuck, full of water, but unable to release it. This is where humans step in. What if we could fix the cloud? The idea behind cloud seeding is simple. Add tiny particles into the cloud that act as hygroscopic nuclei and help droplets grow large enough to fall as precipitation. Scientists discovered that if you introduce the right kind of particles, you can actually trigger this entire process. Early experiments used dry ice. But later scientists found something even more effective. Silver iodide. This substance has a structure almost identical to ice. So when it enters a cloud, it acts as an ice nucleus, helping ice crystals form and grow, ultimately leading to precipitation. And unlike dry ice, it's much easier to use. It can be released from aircraft, or even from ground-based generators, which is what made cloud seeding far more practical and far more widespread. But here's where things get tricky. If you add too many particles, something unexpected happens. The cloud becomes overloaded with ice crystals. Instead of forming large raindrops, you get millions of tiny ice particles, too small to fall. And worse, they start to disappear by turning back into vapor. The result? The cloud can actually stop producing rain completely. In some cases, it even clears out. So yes, you can fix a cloud. But you can also accidentally break it. Not all clouds are cold. Some are warm, with temperatures above freezing. Here, scientists try a different method. They inject salt particles or tiny water droplets. These act as seed drops. As they rise inside the cloud, they collide with smaller droplets, merge together, and grow larger through collision and coalescence. Eventually, they may become heavy enough to fall as rain. But here's the catch. Results are still uncertain. So, now we understand the science. But here's the real question. Is cloud seeding actually helping? Or is it more unpredictable and controversial than we think? Because proving cloud seeding works is surprisingly difficult. Let's say it rains after seeding. How do you know that rain wouldn't have happened anyway? Clouds are already complex systems, and weather changes constantly. So, isolating the exact impact of seeding is extremely hard. Some studies suggest that seeding can result in 5 to 15% increase in precipitation, depending on cloud type, temperature, and how skilled the program is. But other studies show little to no effect. Which is why cloud seeding is often described as a possible enhancement, not a guarantee. Despite uncertainty, many countries still use cloud seeding, because even small gains can matter. It can slightly increase rainfall or snowfall. It may reduce hail damage. It can help clear fog at airports, and even lower pollution levels to some extent. And compared to massive infrastructure projects, it's relatively cheap. So, for water-stressed regions, it's a tempting option. But there's a catch. It only works if clouds with the right temperature and structure already exist. But it is not a cure for drought. Relying on it too much can distract from real solutions like water conservation, groundwater management, and climate adaptation. Then, there's the safety question. The most common agent, silver iodide, is used in extremely small amounts. Most studies show no significant environmental or health risk. But concerns remain, especially about possible long-term accumulation and potential impacts on sensitive ecosystems. And because of this uncertainty, public mistrust can grow, often fueled by conspiracy theories like chemtrails. Now we reach the most controversial part. Who controls the rain? Because cloud seeding doesn't just create rain. It can change where rain falls. Imagine a city upwind, using seeding to steal rain from farmers downwind. It sounds extreme. But this is exactly the kind of conflict experts worry about. That raises serious questions. Could one region take rain from another? Do wealthy cities get priority over farmers? And are communities even informed when this happens? And then there's the biggest risk of all. The illusion of control. Cloud seeding may make it feel like we can control the weather. But in reality, we can only weakly influence it. This doesn't solve the underlying water crisis. Because the real solution isn't just making it rain. It's sustainable water management. So, can we really make it rain? Sometimes, yes. Under the right conditions, we can nudge clouds to release more water. But we're not controlling the weather. We're just influencing it. And the bigger question remains, should we? We are trying to fix something that we don't fully understand yet. If you found this fascinating, make sure to like the video and subscribe for more deep dives into the science of our planet. And tell me in the comments, do you think humans should control the weather or leave nature alone?